Hey guys, this is Mr. H. Hey, I am going to try to do a pretty quick video on how to factorize any number down to the primes. And so I am going to do a couple examples, three examples, some numbers, and then how to factorize them down to primes. So let me just jump into this. Now, very first thing that you need in order to be good at prime factoring is you need to know the divisibility rules. Um, I created this. I created this originally for my son Gabriel when he was younger, trying to show him how to look at any number and tell if it's divisible by another number. So I'm going to go through these quickly. To know if a number is divisible by 2, you just need to look at the last digit. If it's even, 0, 2, 4, 6, 8, then it's divisible by 2. 3, if you want to know if a number is divisible by 3, you just add up all of the digits, and then the sum, if that sum is divisible by 3, then that means the entire number is divisible by 3. All right. 4, a number is divisible by 4 if the last two digits are divisible by 4. So you just have to know whatever the number is, look at the last two digits. If that number is divisible by 4, then the whole number is divisible by 4. 5 is a simple one. You do your counting 5, 10, 15, 20. So anything that ends in a 0 or 5 is divisible by 5. 6, a number is divisible by 6 if it's divisible by both 2 and it's also divisible by 3. So you got to know 2 and 3, the rules for that. If it's divisible by both of those, then it's divisible by 6. 7, now 7 seems a little complicated, but it's not too bad. A number is divisible by 7 if you can take the last digit, double that, and subtract it from the remaining digits. Now, once you've subtracted it, if that difference is divisible by 7, then the entire number is divisible by 7. And then 8 is divisible if the last three digits are divisible by 8. If the number doesn't have 3 digits, basically what I say is if you can divide that number in half 3 times evenly without any remainders, then that number is divisible by 3, or by 8, sorry. 9, it's almost like 3. You take all the digits, you add them up, and then you, if the sum is divisible by 9, then the entire number is divisible by 9. Last one, 10 is really simple. Any number that ends in 0 is divisible by 10, period. Okay, now, I'm going to show you how to use those when you're doing prime factorization. So let me get my iPad oriented. All right, so I got 250 here. I always start with the smallest prime number or the smallest integer, and that's 2. So this is going to be 2. I know it's divisible because the last digit is even, so this is going to be 2, and it's going to be 125. Now, that is not divisible by 2 because it ends in 5. It's not divisible by 3 because it's not divisible by 3 because 7 plus 1 is 8. It's not divisible by 4 because the last two digits aren't divisible by 4. But it is divisible by 5. So we go straight there. It's going to be 5. And that would be 5. Hold on. 5 goes into that 25 times, right? So then you look at 25 and you say, oh, that's also divisible by 5. And now we're done. So the prime factorization for 250 would be 2 times 5 times 5 times 5, which is the same thing as 2 times 5 to the third power. Okay, that's how you prime factorize any number. Now, let's go and try another number. I said 1,000. Okay, so I start with 2. So I say 2, 500, and then I say 2, 250, and then I can keep doing this 2, 125. Now I can't. It's not divisible by 2, it's not divisible by 2, but it is divisible by 5. So that would be 25, and then this would be 5 times 5. So the prime factorization of 1,000 would be 2 to the third power, since we have 1, 2, 3 2s, times 5 to the third power, since we have 1, 2, 3. So this prime factorization tree is very useful, as you can see. Now let me try another number. What's a good number to try here? Let's say 441. Now, is that divisible by 2? No, because the last digit is not even. Is it divisible by 3? Well, let's see. 4 plus 4 is 8. 8 plus 1 is 9. So this is divisible by 3. So let me get rid of those plus signs. So now, what is it actually? Let's see, that'll be 3, 1, 14, that'll be 4, and then 7. Okay, we got 147. Now, is this number divisible by 3? So this would be 11, or 5 plus 7 is 12. So this number is also divisible by 3. So let's see, that'll be 4 times, so 49. Now, this number here is not divisible by 1, is not divisible by 2. Well, oh, sorry, it's not divisible by 2, it's not divisible by 3, it's not divisible by 4, it's not divisible by 5, it's not divisible by 6, but it is divisible by 7. And let me use that divisibility rule. Now, this is a little weird, but obviously you know that this, or if you know your multiplication factor, you know that this is 7 times 7. But I want to show you that even if you didn't know that, if you double this number and subtract it from the remaining, you'll have 4 minus 18, which is a negative 14. But this number is divisible by 7. So that means that this number is divisible by 7. All right, so this is 7 times 7. So the prime factorization is 441 equals 3 squared times 7 squared. All right, so that's how you prime factorize any number. And now remember, when you're factoring, you need to know your divisibility rules. And so if you don't know divisibility rules, it's going to be tougher to get this done. Now, I've gone from 2 through 10, and that should be enough. So that's how you prime factorize any number. I hope this has been helpful. If you don't know these divisibility rules, please try to learn them. All right. And I guess what I'll do is I'll also link put a link in here that shows you how to look at numbers and actually apply these divisibility rules, because some of them are not as obvious. So I will create a video and link it to this video so that if you are struggling with the divisibility rules, you can watch that. Right, I hope this has been helpful. I'm going to sign off.